Okay, so we're working with trigonometric equations now to get the general solution of these equations. The ones we are focusing on today is ones that have this different angles and different functions. With the previous ones we looked at had the same angle, but they had different functions, and then we looked at specific solutions, how to get to those. So you always ask this question: are the angles the same? Are the functions the same? And then from there on you determine which route you're going to take. So over here you can see both are different, functions and angles, but so we can't use our previous methods to solve this one, but what we can do is we can use the reduction formula. Now you will remember that cos 90 minus theta equals sine theta. We are going to apply this just in the opposite direction. We have a sine theta, a sine 75 minus x. So we know in applying this reduction formula, we can rewrite this as cos bracket 90 minus close bracket 75 minus x. So we apply the reduction formula in order to write it down as follows. And now we just go on as we've been doing it previously. We've simplified the right hand side, so the left hand side just stays as is. The right hand side we've got a 90 minus 75, so this becomes 15. And negative x becomes plus x. Okay, so now we've got the same functions, the same definitions, but different angles. And because the definitions are the same, we can then continue like we've done before. So first of all, we can say this is a positive value. So for the cos function, we are working in the first and fourth quadrants. So we're going to have two different solutions. So let's write down our reference angle is 15 plus x. So we can immediately just start off by saying the following: 2x minus 18 equals 15 plus x plus k 360, and we define our k as an element of z. So this is our first part of the solution. So remember to leave some space open, and then from there on we are writing down the second expression of the solution. So 2x minus 18 equals, and now we're in the fourth quadrant. So 360 minus, remember your bracket, plus k 360. So there you have your two expressions. Now we go into our simplification. So 2x minus x becomes an x, and 15 plus 18 is 33, plus k 360. There's our first general solution. Now with the second one, we first have to simplify the right hand side before we can go on. So it's 2x minus 18, 360 minus 15 is 345, then minus x plus k 360. Now we can simplify by bringing the x across, so this becomes a 3x, and then the negative 18 becomes a positive 18, so this will become 363 plus k 360. So let's divide by 3 on both sides. So on the left hand side it becomes an x, on the right hand side 121 plus k times 120. And there you have your two general solutions to this question. Okay, let's move on to the next one, number C. And you will see that it is quite basic expression. Sine 3x minus cos 2x equals 0. And it would be very tempting to say, oh, we move the cos 2x across the equal to sign, divide by it, and we get a tan 3x. But you can see we cannot do that. Why? Because we have two different angles. So keep that in mind. Two different angles, two different functions. We are definitely going to work with the reduction formula. Now in this case, we have the cos theta. So that's where we want to, when we use the reduction formula, it will look like this. Sine 90 minus theta equals cos theta. So that's the one we ending up with. So we basically going in the reverse direction. Okay, let's solve this. So sine 3x equals cos 2x. Sine 3x equals sine 90 minus 2x. Okay, now we have our reference angle. We've got the same functions on both sides. We know it's positive, so we can immediately go on with our cos diagram. And now we're working in the first and the second quadrant. So for our first quadrant, it will look like this. 3x equals 90 minus 2x plus k 360. Okay, so we leave our spaces open, and then you write down our second solution, and this would be in the second quadrant. So it will be 180 minus bracket, remember your bracket please, 90 minus 2x plus k 360. Please remember to define your k value. Okay, let's simplify. The 2x comes across and this becomes a 5x equals 90 plus k 360. And now we can simplify by dividing with a 5 on both sides. So x will become 18 plus k 72. This is the first part of our general solution. It's now simplified and completed. Now the second part, we're first going to simplify the right hand side. So 180 minus 90 is 90 plus 2x plus k 360. We bring the 2 across, it becomes just an x equals 90 plus k 360, and that's our final solution, those two solutions to this equation. So the next one we're working through is number D, and this is the most complex one from this exercise, I would say, because we're incorporating a few things. So first test, we asked ourselves, are the functions the same? No, they're different. Are the angles the same? No, they're also different. So we know we're going to use the reduction formula. But here we've got a negative now, and this, with this, we need to think carefully about which reduction formula we're going to use. You can use any of the two ones that works with sine, but the one will be much shorter. Okay, if you remember correctly from the reduction formula, you know that there's one that ends up with a negative value, and that's cos bracket 90 plus x equals negative sine x. So if we use this reduction formula in the reverse direction, it would be much easier and quicker to solve this one. Okay, so we are going to apply that one. Okay, so first of all, we're just rewriting the left hand side, which is cos bracket 2x plus 30. The right hand side becomes cos bracket 90 plus new bracket x minus 60 close bracket, close the big bracket. And now we've got the same functions, so we can work with this one further. I would first like to simplify the bracket on the right hand side. So 90 minus 60 becomes 30, and the x is an x. Okay. So on the right hand side you can see we've got a positive expression, and on the left hand side as well. So we are working in our cast diagram on the first and the fourth quadrants. Now reference angle is 30 plus x. So our first expression looks like this: 2x plus 30 equals 30 plus x plus k 360, and we define our k as an element of z. Leave some space open, and then we write down our second expression: 2x plus 30 equals 360 minus, remember your bracket, 30 plus x plus k 360. So let's simplify the first one. 2x minus x just becomes an x. 30 minus 30 becomes 0, which is no problem at all. And then for the second expression, we can simplify the right hand side, and it would become 360 minus 30 is 330 minus x plus k 360. Then from here on the x goes across, the left hand side becomes a 3x. The 330 minus 30 becomes 300 plus k 360. Now we divide by 3 on both sides, so the left hand side becomes an x, the right hand side becomes 100 plus k 120. And remember, this first expression, the 0, you just use it as is when you work towards a specific solution, just like you would have with any other angle. So that's it. That's the final solution to this equation.